Hi everyone, I'm Ali and I'm going to talk about our joint work on allocation requires prediction only if inequality is low. So let's get straight to the problem. Consider a resource allocation problem. We have limited resources. We want to allocate them to individuals in need. The question is, do we need individual level predictor in order to have an efficient allocation? Consider, for example, the allocation of educational resources to students. We may use a dropout early warning system here. Such a system will output a risk score per each individual. So based on a budget we have, we can choose the individuals with the highest risk score and intervene on those. Surprisingly, a recent study has found that implementing such a system has had little or no improvement in Wisconsin public schools, despite the fact that they were using a really accurate predictor. There were also consistent observations in prior studies. So there was this conjecture that maybe we observed these insignificant results because the schools were effectively targeting similar students without using such early warning systems. What does that mean? Consider that the students are under two schools, or as we call them later, two units, and maybe the first unit has way more students in risk. Then intervening on the first unit is going to significantly overlap with an intervention mechanism that is using risk score. In this case, using individual predictor is actually unnecessary. This is not really limited to educational setting. We can think about reducing eviction rate by targeting assistance, and this can be done both at the renter level or at the neighborhood level. What is common between these examples is actually there is always a baseline which is targeting at a higher unit level. And in order to answer that whether we need individual level predictions, we have to see what extra value prediction can have compared to these existing units. And a mechanism which is acting based on those units is going to be cheap, it's going to be, very easy to implement, and is somehow less contested. So what we do in this paper is we compare this baseline with a prediction powered allocation in a simple mathematical model. What's the model? Suppose we have some individuals, they have an unknown welfare between 0 and 1. We can intervene on them. That's going to cost C, a fixed cost, and that's going to improve the welfare by delta. Of course, capped at the maximum value. So individuals who have a welfare above 1 minus delta, they're going to observe a diminished effect. The question is how can we spend a fixed budget of B in order to maximize the overall increase in the welfare? That basically means how can we avoid the individuals with high welfare here? And we're going to call this increase in social welfare as the value and compare the mechanisms based on this value. As you may guess, we're going to compare two mechanisms. The first one is individual level allocation. In this mechanism, we first obtain an epsilon accurate predictor that's going to cost a fixed cost of P of epsilon, and then we're going to allocate the rest of the budget for intervention. And ideally, that can be perfectly done. So that's the first mechanism, ILA. The second mechanism is unit level allocation, or ULA. This mechanism is going to intervene at the unit level based on some really rough ranking of the units. And this has a little more detail. We assume that some part of the allocation will be left to the unit administrators, and they can do a fairly good within unit allocation by avoiding the top Q fraction of their members. Uh, I'm going to skip the details here. Really, the main observation we have had is that EULA can dominate ILA when inequality between units exists, or the resources are limited. To be more precise, consider the space of the budget and inequality. Inequality is measured by the Gini index, and this green area is the area where EULA dominates ILA. And when I say dominates, I mean that regardless of the configuration of the problem, as long as that configuration is adhering to the inequality constraint, EULA is going to have a comparable value to ILA. And when I talk about the Gini index, that has some details. I mean the inequality between units. In terms of a parameterization, that parameter is what fraction of individuals in each unit has high welfare. Uh, okay, and if we look at this figure, we have three regimes for the Gini index. If the Gini index is high, that has a formal definition in the paper. That high is not something imaginary. We illustrate this on real data, that this is something that can be realized in a real world. So if the Gini index is high, regardless of what budget we have, EULA is gonna be the dominant solution. Even if the Gini index is not high, if it's in like the medium regime, if the budget is not excessively large, and by that I mean it's not comparable to the cost of treating everyone, still EULA is going to be the dominant solution. And ILA is going to be only relevant actually when the Gini index or the inequality is low and the budget is not too low. So this is actually where we have to think about and we have to take the cost of prediction into account. Um, we also look into what are the conditions that ILA is not dominating EULA. So in other words, EULA is not dominated. And of course, we obtain strictly weaker conditions for that. Uh, I would like to say that we observe similar things when the treatment effect is not necessarily a fixed delta effect. It might be a heterogeneous effect, but it has some conditions like being Lipschitz continuous. Also, we assume that in EULA we can obtain a rough ranking of the units. We might need to learn that, so we take the cost of that into account and obtain similar results. And I would like to also refer you to the paper for an empirical illustration of everything I told you. So thank you, and feel free to reach me at this email.